Hi students, let's look at this question here, which is on application on trigonometric equations in real life. Let's see how we can do this proficiently. So this question I chanced upon on the Facebook group, and let's see how we can actually solve this question here. Okay, so the Singapore Flyer is the world's largest Ferris wheel as in year 2008. Its wheel has a radius of 75 meters and makes a complete revolution of 30 minutes. All right, the bottom of the wheel is 50 meters above the ground, and let h meters be the height of the passengers above the ground T after boarding the compartment at the bottom of the wheel. Okay, so this is at the bottom. We board from the bottom of the wheel and express h as a sine or cosine function of t. So let's see how we can actually do this proficiently. Now, first of all, we of course need to understand what's going on with this question here. Okay, we need to essentially express h as a function of a trigo function of t. Okay, so sometimes if you look at the question like this, it's always good if you can actually sketch out a diagram. Now you don't have to like draw super nice diagram. Okay, so something which you will understand that would do, right? So let's try and understand this. So this is a Ferris wheel. So this is as good as I can get my drawing to draw a Ferris wheel, right? So you were told that this is a Ferris wheel, and initially the bottom of the wheel is 50 meters above the ground. So let's say this is ground level. All these are usual stuff, right? Ground. So here, okay. You're told that the bottom here, the wheel to the ground here, this is 50 meters. Okay, this is 50 meters. Now, and you were also told that the radius is 75 meters. That is actually quite huge. So we're going to just draw this out. 75 meters here. There you go. This is 75 meters. So just bear in mind, anything to do with a circle, the radius is obviously important, right? If you don't have yes, so you know about the radius, of course, you can't really start doing things, right? Now, okay, great. Then we can start doing this question here. Now you need h expressed as sine or cosine function. So which one do you choose, right? Now I will suggest that you try and visualize how these things work. Typically what I will say is, if you're not too sure how it works, it's always good if you can sketch a graph. Okay, graph is a very good tool for mathematicians. Okay, because from a graph, every point contains two information, the y and also the x coordinates, which is pretty neat. Okay, so now you're told that this guy goes in here at t equals to 0. Okay, and you want to express h in terms of t. So naturally, what you want is a function of t, or rather h in terms of a function of t. Okay, so it means h in terms of t. So I'm going to just try and sketch this graph here. So this part here, we just draw this out. Okay, then what we're going to do is actually just try and understand here. At the time t here, of course this is t, this is h. At time t, the person has to be 50 meters above ground, right? So this is 50 meters above ground. And you're told that it will just go up one round here and come down. And it takes how long? A period. It's actually 30 minutes, okay? So naturally, you would think that if this is 30 minutes going one round, and assuming that it's a constant, they say it's constant revolution, complete revolution. Okay, so it should say that it's a constant revolution, because sometimes you can speed up. We just assume that it's constant. What we're going to do is actually just go up and come down here. Okay, so we know that at time, if this is time 30 minutes, right? So at the peak here, if it's a constant rate, this will be 50 minutes, right? Correct. So what we need to know is actually at the peak here, so at 0, at peak here is 15 minutes and this is 30. So at the peak, what we will get is actually 75 plus 75. You just bring out a calculator. 75 plus 75, that's 150, right? 150 plus 15, that will give us 25, 75, 165. So this 165. So we know that at the peak, 50 minutes, it will be here. Okay, and after which it will come back down again, which is here. Okay, so how do you draw this graph? Obviously, you're not going to draw the graph goes up in a sharp bend, right? When you are sitting in a Ferris wheel, what happens is actually you realize that when you're moving this direction here, when you're at the bottom point here, is the slowest moving. You don't feel like you're going vertically upwards as fast as when you're here. Okay, at this point here, you will feel that you actually elevate faster than at the bottom point. Then after which you will slow down in terms of your elevation, and then after you speed up again going down, right? So actually it's a smooth curve up. So this curve will go up like that, and this will come down like that. Okay, so I would suggest, if you're not too sure how to solve this question here, you can actually just try and sketch a curve out. Okay, then you'll be able to see. But of course, if you're not if you're able to use another method, which is using the formula, it works as well. But I would suggest just use this. It's the same thing. Okay. Anyway, I think I solved the graph function of C. Okay. Anyway, now this is it. So we know that this function here is y equals to a cos bt plus c. All right. Now, first thing first. This is not the y equals to cosine curve. We know that y equals to cosine x. Okay, y equals to cosine x is a cosine curve, starts from 1 and ends deep down to -1. Whereas if it's y equals to negative cosine x, we know that it starts from -1, goes up and come down. Right. So this is equilibrium line. So same thing, this equilibrium line here is your C, right? So this case here, this is actually negative cosine x. So A would be the height here, the amplitude is actually 75, right? So here A should be a -75. I'm using a cosine because it starts from negative. Okay, it doesn't start from the equilibrium line. It starts from in the negative part here. So this is -75. Then after which we have got period is actually 30 minutes. Right? Period is 30 minutes, and we know that period in terms of period is 2 pi over b, and this is 30, and essentially b is equals to pi over 15. All right. C will be this line here. So C is actually y equals to c here. So this is quite straightforward. This C here is just 165 plus 15 over 2. All right. So just sum it up. 165 plus 15 over 2. That will give us 90. So this is 90. 165 plus 15 over 2, which is 90. Okay. So this case here, this will be C equals to 90 here. So hence, the equation, the express H so H will just be -75 cosine pi over 15 t plus 90. Okay, so you can just substitute t equals to 0. T equals to 0 will be +1, which will give you 15. You can see that actually it works out well. All right, so that's how you actually do the first part here. This is the equation. Of course, you can actually express in terms of sine. Just remember that it's just a phase shifting, but I'm not going to use sine because it will be quite confusing. So we're just going to stick to cosine. Okay, cosine because it starts from the deep and it doesn't start from the line of equilibrium.